So here we are finally at part 4 of the Zippy microservice structure and functionality. And here's where we're actually going to talk about how the Zippy service class is implemented and how it actually applies the Jakarta Persistence API. And when we look at the implementation, you'll see we have just a tad bit of Java parallel and/or sequential streams in one of the implementations. In real life, we would do something more sophisticated, but I wanted to keep this simple for various reasons having to do with upcoming assignments. So the Zippy service defines the implementation methods that the Zippy controller calls when it gets HTTP requests from clients. And of course, this implements the base service, which we saw before. And the base service, in turn, is parameterized with the list of quote objects. So that pretty much the same what we saw before with the controller, except now we're doing the nitty-gritty part of the implementation. As usual, we annotate the Zippy service with the @service annotation to inform Spring that this is the business logic part of the microservice, and it will go ahead and do auto detection and wiring of dependent classes via class path scanning. Here's what we're going to auto wire. We're going to auto wire the Zippy quote repository. And remember, this is the repository that's going to keep track of all the Zippy quotes. This is the data.sql file that contains all the Zippy quotes. And when we walk through the implementation, you'll see how this is used. So let's take a look at some of the methods. So here's the getAllQuotes method, which returns all the Zippy quote objects that are part of that database. And the way it does it is by using the automatically generated JPA method called findAll, which comes from the CRUD repository, and that returns all the Zippy quote objects in the database. And effectively what this is doing is it's just doing a select everything from the quote table, and so we're just going to get back all the Zippy quotes that you can see here. Note something interesting, however. We add the @cacheable annotation, which is an instruction to Spring to cache the list of quote objects in memory on the server side. So the first time this method is called from a client, it will actually go and do that query against the database, and then it caches it in the Zippy cache, which is just a string we give it. And the second and subsequent times a client invokes this, then it'll return the contents from the cache rather than going back to the database. So at least in theory, that could make things run a lot faster under certain circumstances. Let's take a look at the getQuote method. The getQuote method takes a quote ID sent by the client, and it's going to return the associated Zippy quote. And the way this works is it uses the automatically generated findById method, which comes from the CRUD repository again, to get the quote out of the database. Now, if for some reason someone gives a quote ID that isn't found, then this will throw the illegal argument exception back to the client, which is what we want. Assuming that the quote ID is valid, like you want Zippy quote 674, then it will go and select from the quote table the quote with that particular ID, which comes back with what I need is a mature relationship with a floppy disk, which is a classic Zippy quote. Note again, we use the cacheable annotation, except this time we're going to cache on a quote ID basis. So each time someone gives the same quote ID more than once, each time a client asks for the same quote ID, the first time through, it'll go ahead and look at the repository and get it through this query. And then the second and subsequent times, it'll just return that item based on the quote ID that was cached, which may or may not be any faster than actually doing the lookup on the database, but I'm just showing you how the mechanisms work. You can decide if it's worth doing it or not. Let's take a look at another interesting method. This is the postQuotes method. And what this does is it finds all the quote objects that match the quote ID's list parameter. So this is a list of integers, list of quote IDs. In this case, it uses the auto-generated JPA method to find all the quote objects matching the quote IDs, which is what you can see here. So once again, this comes from another pre-generated set of methods from the list CRUD repository. And in this case, it's the findAllById method, which, as you can see, takes an iterable or a list or collection or whatnot, and it returns a list of items. This is what this would look like if you were to search for quote IDs 27, 61, 133, and 757. You would end up with these quotes that come back here, and that's equivalent to the SQL query. Select anything that matches from the quote table where the ID is in this list, which is provided there as 27, 61, 133, and 757. Let's take a look at another method, and this is going to be a method that's a hybrid. It's going to include both calls to auto-generated Spring Data API methods, as well as encompassing them or enclosing them in some Java Streams code. This is going to find the quote objects that match any query in this list of query strings. So this is basically an OR, if you will. And here's what we're going to do. We're going to use the find by quote containing ignore case method, which was automatically generated using the keywords in the Spring Data API in the Zippy quote repository to find quotes that match a given query in the list of queries. So for example, if someone wants to match Yao, these are some things we're going to get matching. And in this case, as we talked about before, we're going to select anything from the quote table where the lowercase quote field or column is going to be matched by the lowercase query. It doesn't have to be a perfect match, it just has to be a subset. And then what we're going to do is we're going to encapsulate that particular mechanism with either a parallel or a sequential Java stream. So we're going to go ahead and take the list of queries, turn it into a stream of queries that will either be a parallel or sequential stream based on the parameter passed by the client. Then we're going to use the M repository find by quote containing ignore case generated method to find anything that matches. That'll return a list, which we're going to turn into a stream, and then we're going to flat map all those things together and then weed out any duplicates and return the unique set of quotes as a list. And notice what we're doing here. For example, we say Yao or yet. So if we put Yao and the yet string in our list of strings in the queries parameter, these are the things that will match. So anything with a Yao in it will match. Anything with a yet in it will match. And we need to use distinct here, and that's because if you have things where you have Yao and yet, you can match multiple times. For example, Yao, am I cleansed yet, will match both with Yao and will also match with yet. So we have to weed them out by using distinct. Now, this is not the best way of doing things. I'm just showing you how you could do it if you didn't want to take the trouble of writing a custom mechanism, a custom query to do the ORing together. And you can do that, and that will be part of an assignment that will be coming up. But for now, I'm showing you how you can do it by writing code that is imperative code using Java streams. And then the last piece of the puzzle here is the search EX method, which is going to find all the quote objects in the database that contain all of the queries. And in this case, we're going to call our custom SQL query find all by quote containing all in. And you can see here that that's going to take the list of queries and it's going to find all the quote objects containing all of the queries. And so that's effectively what we show here. So where we put Yao and yet, so it's basically an and operation. All the elements in the queries list must match in a string for it to show up here as a result of this. And you can see what we get. Yao, am I cleansed yet? Yao, am I having fun yet? Yao, are we laid back yet? Because Yao and yet appear in all of those strings. So the corresponding SQL query that we actually write ourselves is selecting anything from quote where lowercase quote is like Yao and the lowercase quote is like yet. So that's the end of part 4. And as I mentioned before, each of these things we're discussing here are things you'll have to understand. Each of these features are things you'll have to understand for upcoming assignments.